Hello, everyone. Thank you for joining us today. We'll get started here in a moment. It's not quite 4:05. I'm pretty sure my microphone is on. Yes, it is. And excuse me. But yeah, I want to apologize for such short notice having this class on Zoom today. Woke up this morning with a fever. I'm fine now, but I work at two schools and COVID protocols that both say, don't come back until you have a negative test. Did get tested today. Don't have the result back yet. I'm going to check on that real quick. Results pending. Got to log back in. Results are still pending. With this place, they're pretty quick turnaround time. So hopefully I will get the all clear to return to school tomorrow, which really wouldn't affect y'all because I won't see you until Wednesday. Excuse me. We'll get started here in just a moment. I believe right now I am screen sharing a blank whiteboard. So let me just go ahead and type little get started thing here. Today is not Wednesday. It is Monday, November the 8th, 2021. This is Math 1324, Section 5 at UT Tyler. Bump the font size up just a little bit. Hope everybody had a good weekend. And I know the first question some of you are going to ask is, what is my test grade? And the answer is, I don't know yet. I anticipated that question in the chat. Again, I have not had an opportunity to even get the test yet because I have not been on campus since last Monday. This past Thursday and Friday, I simply did not have time to go to campus. My plan was to pick up the test today, and obviously that didn't happen. So test grades are still pending. And I know some of you are just anxiously awaiting knowing what your test grade is, and I do appreciate your patience. We'll get those grades to you as soon as possible. Also, before we get started, some of you may have just gotten a notification in Canvas about a quiz and whatnot. I'm going to share my browser so that I can show you just exactly what happened. I did post this announcement about quiz not available, and it is due by class time on Wednesday. I know that's a quick turnaround time for quizzes. Let me start recording this. I think it's already recording. It is recording. I know that's a quick turnaround time on a quiz, but it's critical that you practice the skills that you're going to learn today because you can't move forward until you do. So we're not going to have this week plus to do this quiz. It needs to be done before you come to class on Wednesday. And in fact, if you go to that quiz, it will say that it is due at 4:05 p.m. on Wednesday, which is when class starts on Wednesday. So please do the quiz as soon as you can, and it will be over in the material that you'll see today. And you may have also noticed that both in this quiz and in the announcement, there was a link about a z-distribution table. I've already got that table open. I thought I had it open. We'll open it now. This is something that you may be familiar with. Let me hide all this. This is something you may be familiar with, but if you're not, then you need to get really familiar with it really soon. We'll explain what all this is, and it's really not that difficult to use, but it is going to be a tool that is going to allow us to not have to worry about bootstrapping distributions or randomization distributions from this point forward. I want to show me. I don't want to show Esteban. I want to show me. Just me. Everybody else disappear. How do I make that happen? I know there's a way to make it happen. 1 second, folks. I just want to show me. Nothing against everybody else. But, oh, well, that's okay. Y'all don't need to see me. You know what I look like. All right. So like I said, I hope everybody had a good weekend. I am feeling okay. Just a precautionary measure because I'm supposed to do things like that. All right. Before we get started, does anybody have any questions you would like to ask besides what did I make on the test? You can either type them in the chat or you can unmute your microphone. Give people a second to do that. Looks like we got one in the chat. Just ready to learn what I need today for the quiz. Well, I hope you're ready to learn that and then some. And to be honest with you, the stuff we're going to learn today is actually not that difficult. Once you understand how this distribution table works, this thing right here, then you'll be set to go. Now, word of advice, this file, which you can find either, let's see, either in the announcement of the quiz, or if you go to the quiz itself, there's a link for it, or you can click on files, and there is a folder titled distribution tables, and you'll see a Z distribution. Now there's also a T distribution, which we'll get to later, but we're going to focus only on the Z distribution today. So let's go back to the whiteboard for a second. All right. And 1 second, folks, I just got an urgent text that I need to reply to real fast. Really? In a Zoom class right now. Okay. All right. So as I mentioned, we are going to start talking about what's called the Z table or the Z distribution. Now, its full name is called the standard normal distribution. And all those words mean something. When you see the word normal, and we've seen the word normal before, normal basically just means bell curve. So anytime you see the word normal, you can just assume that it means bell curve. So we're going to be drawing lots of bell curves. But what makes a normal distribution standard? Well, there's something very specific that makes a normal distribution standard. What makes a normal distribution standard is its mean and standard deviation. A standard normal distribution, let me widen this real quick, has a mean of 0 and a standard deviation of 1. And if we were to write it using the correct variables, we are going to assume this is on the population level. So we're going to say mu is equal to 0 and sigma is equal to 1. And again, that's only if it says standard. Now, most of the time when you have data that's bell curved, it doesn't have a mean of 0 and it doesn't have a standard deviation of 1, but we'll be able to standardize normal distributions when the time is right, meaning even if a distribution doesn't have a mean of 0 or a standard deviation of 1, we can kind of trick it into acting like it does and then use that chart that I showed you with all those numbers. All right. Let's see, what else do we need to do before we whip out the Z chart? Every problem that we're going to do today, and this is worth typing, but every problem we're going to do today has an associated bell curve. And I recommend that you draw it. And on your next test, every time you have a question that uses the Z chart, I will ask you to draw the bell curve. Now, if you are in a standard normal distribution curve, as opposed to just normal, normal just means bell curve. Standard normal means bell curve. The mean is 0, and in a bell curve, the mean is always in the middle. Now, when we draw a standard normal distribution, we're always going to write the letter Z over here. That's going to be the variable that's being measured on that horizontal axis going across the bottom. And that Z is the same Z-score that we saw once upon a time. We haven't talked about it much lately, so just a reminder about what a Z-score is. A Z-score, let me widen this text box and take the font size down just for a second. A Z-score is a measurement for a value that measures the number of standard deviations a value is from the mean. But for now, you can just assume that it's a number on the spot on the bottom of this number line. And later, when we have non-standard normal distributions, in other words, bell curves whose middle aren't necessarily 0 and whose standard deviations aren't necessarily 1, then we'll review what it means to be a z-score, because that will help us turn any normal distribution into a standard normal distribution. All right, so let's get, we'll get right to the problems in just a second. But there's one more thing I want to remind you of, and this is something that's popped up a lot when we talked about hypothesis testing, and that's about the relationship between the area under a bell curve and probabilities. So recall the following, that under a bell curve, the area represents the probability of, with that, for lack of a better phrase, landing in that region of the bell curve. For example, if we had a bell curve, well, let's say we have a distribution. And remember, all that means is we got a bunch of numbers that have a mean and a standard deviation. And although they technically don't make a smooth curve, we can treat it as if it does and get a good approximation for the things that we're going to do. So we're going to replace all of our dot plots, you know, the ones that kind of went dot, 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 and assume that under the right conditions, and we'll get to what those conditions are in chapter 6, assume that under the right conditions are dot plots that we get from bootstrapping distributions or from randomization distributions. We'll have the correct conditions to assume that they act like a bell curve, and therefore we can do all of our work with this picture and with the z-chart that we're going to be looking at soon. But when I say that under a bell curve, the area represents the probability of landing in that region of the bell curve, if we had, say, a standard normal distribution whose mean is 0 and standard deviation is 1, most of the time I'll just write the standard deviation off in the upper right-hand corner. You can actually write it anywhere. And let's say that we put a 1.62 here, and we shade the area to the right of that. Then this right area is the probability that z is greater than 1.62. Greater than because we're to the right of 1.62. In other words, if we had a z that landed over here or over here or over here somewhere, then the probability that the z on the number line would land to the right of 1.62 is whatever that right tail area is. And if we knew the area of that, then we would have the answer to that question, what the probability is. Or if we knew the area to the left, it would be the probability that you're less than 1.62. In fact, I'll go ahead and write that. Let's see, this is in dark green. This area is the probability that z is less than 1.62. And in both of them, we could say or equal to. The nice thing about a continuous bell curve like this is the probability of being on an exact value, in other words, the probability of being exactly z equals 1.62 is actually 0. We're not going to get into the nitpicky details as to why that is, because the authors of this book don't go so much into the theoretical side of things. But whenever we say less than, it's the same thing as less than or equal to in terms of these probabilities. And the same thing if we say greater than, it's the same thing as greater than or equal to in terms of these probabilities. All right, so let's get to it. Let's figure out how to calculate the areas under a curve when we know the z-score, and then we'll do it backwards as well. In fact, I've got a few things that I'm going to attempt to do. Finding areas under a standard normal distribution, such as finding that red area or the green area, and backwards. Backwards meaning if I tell you one of those areas, can you tell me the z-score that cuts it off? And then we're going to talk about standardizing a normal distribution. And if we have time, we'll talk about how this fits into hypothesis testing. But if we don't, that's okay. All right, so let us begin. Let's start with what the z-chart tells us. So we'll ask the question, what does the z-chart tell us? Well, we'll go over to the chart in just a second, but I want to go ahead and sketch a standard normal distribution. Now, before I do this first problem, I should tell you that all the questions on that quiz are like what you're about to see from now until the end of this video. Let's go to the z-chart and take a look at it. Got a lot of people on here. All right, z-chart, where did you go? You are here, right there. I have a paper copy of this to give you. You don't need to print one out. If you want to print one out between now and Wednesday, that's fine. It is a 2-page document. The paper copies that I have to give you are printed on both the front and the back. So it's a single page printed on both sides. But the top of this document kind of describes exactly what's going on a little bit. Cumulative area, total area, under a standard normal distribution curve to the left, in all caps, of a given z-score. The numbers inside this table represent areas. That's an area, that's an area, that's an area. And if we keep going, all these numbers in the middle, all these 4-digit decimals are areas under the z-score. And if you notice, they're all less than 1. The reason that is because we're going to think of the areas under the bell curve in terms of percent. And so the total area under the bell curve would be 100%. As a decimal, that's the number 1. So all of these areas are less than 1 because as percents, that makes them less than 100%. So those are the areas. But what's going on the edges of the z-chart? In the upper left corner, you see the letter z. And in the top row, you see all of these 2-digit decimals going from 0.00 to 0.09. And below the Z in the left column, you see all of these 2-digit numbers that have a one digit to the left of the decimal and 1 digit to the right of the decimal. The left column, coupled with the top row, tell you a z-score corresponding to an area inside of the z-chart. For example, let's say that we grab this 0.55 here. The numbers in the middle represent areas to the left. So that represents a left area, but to the left of what? To read a z-score from the chart, assuming you have an area that you're looking at, if you look to the left, it will tell you, let me highlight this. We want to find the z-score that has that area to the left of it. To find the z-score, go all the way to the left and see which row you're in, -2.5, and then go to the top of whichever column you're in and see what you have up there. Your z-score is the sum of the numbers on the left and the number on the top. And I should be careful saying that because technically one of those numbers is negative, the -2.5, and the other one's positive. So ignoring the negative for just a second, if I were to add those, I'd get 2.54. But negative. Another way of thinking about it is that the number on the left, the -2.5, tells you the digits to the left and to the right of the decimal, and the number on the top tells you the second digit after the decimal. So this z-score is -2.54. So in the picture, it will look something like this. Remembering that zero's in the middle, -2.54 would be over here somewhere on the z number line. If we go up to the curve and shade in the left area, then what the z-chart tells us, go back to it, what the z-chart tells us is that the area to the left of -2.54 is 0.0055. 0.0055. Area equals 0.0055. Or if you wanted to write it as a percent by moving the decimal 2 places to the right, 0.55%. So not even 1% of the curve is to the left of z equals -2.54. But that's really all the z-chart tells us. It tells us if you have the z-score, which you can measure accurate to 2 decimal places, then I can tell you the area to the left of it. Let's pose another one. And by the way, if you want to try to answer some of these questions, I encourage you right now in the middle of the Zoom session to go into Canvas, and the direct place to find the Z-chart is under Files. Go into the folder that says Distribution Tables and click the one that says zdistribution.pdf. It will open in a frame inside like this, but you probably want to download it and open it in a separate tab like I just did. I'm going to close that one because I've already got one open. But it will benefit you if you can practice using the Z-chart right now. All right, let's get back to the whiteboard. And I'm going to pose a question, and I'd like you to try to see if you can find that area to the left of a Z-score. All right, so the question I'd like for you to answer is to find the area to the left of Z equals, we'll say negative 1.04, comma, under the standard normal distribution. Now, to help you out, I'll get the picture drawn. But on your next test, I will ask you for every question like this to draw the associated bell curve. It's not that hard to do. If you are a standard normal distribution, then you're measuring Z-scores. 0 is always in the middle. I assume you know where negative 1.04 is. Check something real quick. I do not know the answer yet. You may be right. Somebody gave me a direct message for the answer. But to draw a picture of this, draw the bell curve, Z, label the axis Z because we're measuring Z-scores. 0 is always in the middle for a standard normal distribution. Negative 1.4, of course, is to the left of 0. Shoot a line up to the curve, shade in the area, and it doesn't have to be totally shaded in, just put some effort into it. And the question is, what's this area? Well, our Z-chart tells us that area. Now, if you've already looked it up, then in the chat, send me a private message or a direct message so you don't give the answer away to anybody else. I've already had one person to do it. Let's see if we can get another one or two. And if you don't have the Z-chart in front of you, I will be opening it here in just a second. We've got the same answer from two different people, from Sitlalith and from Lucas. Now, the answers are the same. I didn't say that they were correct, but they do agree. So at the very least, their answer is popular, at least as popular as something can be amongst two people. All right, let me open up the Z distribution in case you don't have it open in front of you. And we're looking for the area to the left of negative 1.04. Let's see. I think somebody actually texted me their answer. They did. Okay, another option for sending me your answer choice. You can send me a picture of it as Dylan just did. And Dylan, you have the same answer as Lucas and Sitlalith. Let me erase the highlights that are here. And now we need to find negative 1.04. To find negative 1.04, start by looking for negative 1.0 in the left column, because that will identify the row you need to look across. Now, one of the problems with using the Z-chart online is that you lose sight of the top row. You can count from left to right to figure out where the 4 is, but be careful. If you count from left to right to find the correct column, remember that the first column actually represents the number 0, not the number 1. So if you count left to right, once you found the correct row, make sure you start counting with 0. So negative 1.00, 1, 2, 3, and 4, which is right there. It looks like the correct answer is when Columbus sailed the ocean blue, 1492, which is the answer that everybody who submitted an answer got. So thank you, Dylan. Thank you, Sitlalith, and thank you, Lucas. You all had the correct area. The area, according to the chart, was 0.1492, or as a percent, 14.92%. And if we did more probability in this class, we would interpret them as percents, because we would ask questions like, what's the probability of this? And saying 14.92% makes a little bit more sense. All right, before we move on, does anybody have any questions about where I got that area in the Z chart. Feel free to unmute your microphone, send me a text, or put something in the chat. I'll give you a chance to do that while I take a swig of my Dr. Pepper Zero, which you can't see because my video is turned off right now. Well, I don't know. I have a question for all of you who are watching right now. On my side, I've got the videos reduced so that I can't see them. Do y'all have the option of seeing me on a video right now?
Yes, sir, we can see you.
So y'all can see zeros right now. Y'all can see me. Oh, okay. I got to keep that in mind because I'm not seeing me, so I don't want to do something stupid. I may already have. So some of you did see the Dr. Pepper. Okay, I didn't know if the video display that I had matched the video display that y'all had. So I'll just go ahead and leave all the videos open. Well, just mine. I don't see anybody else. Okay, so if there are no questions about where this one came from, then we're going to move on to another example. And the TJC background is on. I know that's my default. You really wanted to, well, not that it matters. I'm not going to waste your time changing it to my UT Tyler background. Okay. The first 4 questions on your quiz are just like this. So to give you a chance to practice, those of you who are actually practicing right now, I'm going to set up, we'll say 3 pictures as I drop my stylus. I'm going to set up 3 pictures, and the question for all of them is the same. What's the area? Now you can assume all of these are Z's with 0 in the middle. Okay, we're going to put a 1.75 here and shade the left area. So these are all going to work exactly the same. 0 here. Let's put a 0.99, and we'll shade that area. And then we'll do one more in the room that I got right here. And in case you're wondering where that third one is, it's right at 0. So it actually hits right at 0. All right, so I'll give you a second to crank out all 3 of those. And I can't share the whiteboard and the Z distribution at the same time. So if you're drawing this, I'll give you a second to draw those pictures, and then I'll switch back over to the Z distribution. Although I don't know how much good it's going to do because I have to scroll through it. I'm going to switch over to the Z distribution. $1.75, 99 cents, and 0. One thing I didn't mention about the Z distribution is that the front page, the first page, has negative Z's, and when you hit the page break, it switches into positive Z's. So everything you need is now on the screen. In fact, I can even scroll down a little bit more. All right, so all 3 numbers you need are on the screen. And again, the first one was the area to the left of 1.75. The second one was the area to the left of 0.99. And the third one is the area to the left of 0 itself. If you get any of the answers, 1, 2, or all 3 of them, put them in the chat and or send me a text. And again, if you put them in the chat, do me a favor and do a direct message to me so that you don't spoil the answer for everybody else. I've got a couple of chats going. Let's see. Oh, and to be honest with you, I don't know what the answers are yet because I hadn't looked them up. But I'm glancing at them now, and I'll be replying to you verbally. Lalith, your first one is correct. Lucas, your first one is correct. Your second one is not correct, and your third one is. Lucas, I think your second one is incorrect. Unless I misremembered the problem. Let me look at it real quick. Oh, Lucas, I take that back. I looked up the wrong one on your second one. It was $1.75, 99 cents, and 0. So let me check again, Lucas. Hold on. And Dylan sent me pictures of his. All right. So where is I take that back, Lucas? All 3 of yours were correct. Sitlalath, your second and third ones are correct. If you think you're doing it right, Caitlin, I'll know if you send me some answers to look at. All right, Karina, your first two are correct. Let's see, Sitlalath, all of yours are correct. Karina, your third one is correct. Caitlin, your last one is correct, but I think the reason your first two are not is I think you might be looking up the negative numbers instead of the positive numbers. Jordan, yours look good. Let me look at Dylan's. Let's see. Dylan. That one looks good. That one looks good. Let me look at Azaria's. Nicely drawn pictures, ma'am. And all three of yours look good. All right, I think some of you have already had some experience in doing this. And if you have, that's great. And if you haven't, that's okay. Also, I want to mention that some of you may have experience getting these values, but not using a table, using a calculator, like a TI graphing calculator and the statistical capabilities that it has. If you have one of those calculators, that's okay. But because I don't want to require everybody to purchase the same type of calculator, I am going to do all of these questions using this chart. If you want to use a calculator to back up your answer, that's fine, but I do want you to be familiar with this chart. All right, let's go ahead and crank out these answers, and I appreciate all of those who sent me some answers. All right, well, we just got to look up 175. I look at these as dollars and cents, $1.75, 99 cents, and some of you got a little bit thrown off by the zero, but that's one that we can actually do without the chart if you think about it. All right, let's look up 1.75 in the Z chart. 1.75. All right, 1.75. That would be, here's the 1.7. And then the fifth column is right here. That row and that column intersect here at 0.9599. So the area to the left of 1.75 is 0.9599, or as a percent, 95.99%. Now, before we go any further, I need to squash something right now. For the first question, some of you had sent this in the chat. And I know what you mean when you say that. But if you were to walk up to somebody on the street and say 1.75 equals 0.9599, they'd look at you like you're a little crazy. I know what you mean, but that's not what you said. So I want to really, right now, I want to get you out of the habit of comparing two different types of objects. And when I say two different types of objects, what I mean is this 1.75 is a Z-score, but this guy is an area, and you shouldn't be comparing them to each other. There is a relationship between the two of them, but they're not flat out equal to each other. If you really want to say something, you should say something like this. And I think I can fit it in this little corner up here. One second. I think you should say something like this. The area to the left of Z equals 1.75 is 0.9599. But I need to break you of the habit right now of saying a Z-score is equal to an area. It's like comparing apples and oranges. You can't compare them to each other. And don't say something like 1.75 equals 0.9599. It's a real tempting thing to do, but I think we can all agree that those two numbers are not equal. They're related to each other, but not that way. All right, let's get back to the 0.99, the second picture. If we go to the Z chart and find 0.99, I'll change the highlighting color. 0.9 in the left column is here, and then 9 is in the last column, and the intersection of those is 0.8389, which is that area. So this area, oops, come back here. This area equals 0.8389. It's okay to leave them as decimals. I guess I could have just typed that. If you want to turn them into percents, that's fine. But we will be doing math with these numbers, and they're easy to do math with as decimals instead of areas. All right, instead of percents. All right, so for the last one, you really didn't need the Z chart. Would anybody care to unmute their microphone and explain how you can get the answer to this last one without even using the Z-chart? Don't be shy. How about I use the Z-chart and then I'll let somebody chime in. Uh-oh, we got somebody chatting it up. 50% because I shaded in half of it. That's exactly right. It should be 50%. It should be 50% because it's symmetric and the total area is 100%. So if the answer is not 50%, then something's not going on. Something wrong is going on here. But it is 50% if you go to the Z-chart because, come on, let me, thank you. Because if you go to 0.00, then the area to the left of it is 50%. It's also the area to the right of it. It's the only Z-score where the left and the right areas are the same. All right. So before we move on, does anybody have any questions about using the Z-chart to locate left areas to the left of a Z-score? All right. Well, the next thing we need to do is talk about finding areas to the right of a Z-score. So how to find the area to the right of a Z-score. Let's pose a question and then we'll think about it. And if anybody thinks they have an idea on how to do that, I'd like it if you'd chime in. That's not what I meant to do. I'd like it if you'd get ready to unmute your microphone and contribute to the discussion. Because even though I'm leading the charge here, this is our class, and just like any other class, anybody is welcome to participate. For example, let's go over here to z equals 0.25. And we want to find the area to the right, which I'll shade in green just to be different. Now, before we look up this area, and this is an important skill to have, if you draw a picture, you should be able to gauge a reasonable answer for your area in terms of, is it more than half or less than half? The answer to this should clearly be less than 1/2, because half of it would be everything to the right of that line, which is not a very good line, but you know what I was going for. But it's less than the right half of the curve. So my answer should be less than 1/2. I'm going to pull up the Z-chart, and I'd like for somebody to, if you're up to it, and I hope somebody is, to tell me, how can I use the Z-chart to find the area to the right of Z equals 2.5? As I get rid of these highlights. And by the way, if you just look up 0.25, if you just look up 0.25, there's no way this could be the answer, because we've already decided that our answer was supposed to be less than 50%. And that answer is greater than 50%. It's greater than 1/2. So any suggestions on how to find the right area, keeping in mind that our Z-chart only tells us left area? You can type it if you want. Be quicker if you just unmuted a microphone.
You just subtract it by 1.
We got a couple of chats going on. Let's see what's going on here. Well, the good news is you got a couple of chat messages. The not so good news is that they're all from the same person, which I want them to keep participating, but I'd like for more people to jump in as well. Of course, if you just logged into Zoom and walked away and did something else, then I can't really help you much. Is there a formula? Sort of, but I mean, as a formula, it's the most minimal possible formula you could probably ever see. I take that back. I've seen a formula that said one thing equals another. No calculations. It just said this equals that. It was more of an observation. All right. If you're not sure how to find the area to the right, let's think about what our chart does tell us. Our chart tells us the area to the left. And Isabella is asking everybody, do you subtract it by 1? Well, yes. That's exactly what you do, Isabella. Thanks for jumping in there. I appreciate it. But to really give it some credence and some definitiveness, let's just focus on what the green area here really represents, the 0.5987. Our Z-chart tells us the area to the left. So we know that this left area, and I'll type this, we know that the left area is I think I said 5987. I'll go back and look real quick. Yes, 0.5987. But we also know that the total area is equal to 1. Let me jump back in here for a second. This is from the chart. That's what our chart tells us. Our chart tells us the area is to the left of something. However, the total area has to equal 1. So if the total equals 1 and we know the left, then we can figure out the right by subtracting. Now, so Lala, you were asking, is there a formula? And the answer is sort of. But if you really want a formula for a right area, here it is. The right area, and courtesy of Isabella, the right area is just equal to 1 minus the left area. By the way, this works both ways. The left area is equal to the 1 minus the right area as well. But it's consequence of both halves adding up to 1. So if you know 1, you just subtract from 1 to find the other. So if I wanted to find the right area here, then the right area is equal to 1 minus 0.5987, which is equal to 0.4013, I believe. Yeah, that sounds good. And I'm not sure why I typed that in red when I drew it in green, so we'll just make it green. All right, and that would be our right area. And in general, to find a right area, it's always 1 minus the left area. Now, to me, that's not a formula, it's more of a concept. And the reason I'm telling you that is because I will not give you that as a formula on your next test. You just have to know that the right area is equal to 1 minus the left area. All right, does anybody have any questions about how we found the right area of 0.4013? We got something going in the chat. So we memorize it. Okay, asking you to memorize this should not be that unreasonable. It's not that hard. It's not that difficult. Like I said, it's more of a concept. The total area is equal to 1. So if you know a piece of it, then 1 minus it is the other piece of it. All right, I want to throw a couple up here, and we'll just do a couple for you to try. So if you have a Z chart handy, get ready. And the directions, of course, are going to find the right area. Put this back in black. Cue ACDC there. All right, so find the right area. So for the first one, we'll go to the left over here, and let's put a negative 1.38. The question is, what's that area to the right? And then for the other one, let's throw a Z way out to the right. Let's go to 3.10. All right, so see if you can find the area to the right of negative 1.38 and the area to the right of 3.10. And as you're looking them up, keep in mind, how big should they be relative to half? One should be more than half, more than 50%. The other should be less than. Okay, do I have a paper Z chart on me so I don't have to keep flipping back and forth? Wait, I see. Oh, I got one. Got one. All right, so let me find my answers. Okay, there's one. And then the other one, 3.10. Ooh, that's not much area. Okay, I've got both answers ready. So if you have the right area for either one, you can send them to me. I am going to switch over to the Z table. The problem is one of our Z's is negative, one of them is positive. So I can't show both unless I zoom out really far, in which case you may not be able to see. I don't remember what the Z's were now. 1 second, folks. Negative 1.38 and 3.10. And I believe we got somebody in the chat. The area to the right is from Lucas. The area to the right of negative 1.38 is that. I agree. And the area to the right of 3.10 is that. I also agree. All right. So I got one pair of correct answers. I think another chat popped up as soon as I closed it. And let's see, Karina has one answer, which is Where are you? There you are. I'm replying directly to some people. And I see one person is giving me 2 negative answers, but areas are never negative. And if you're subtracting from 1, make sure you're subtracting the correct thing from 1. And it also is worth mentioning that the order that you subtract things in matters. So be very careful when you do the subtraction and that you do it at the right time. Okay, so let's go ahead and let's see. I got a couple more chaps popping up. Oh, I see my error. Good. All right, let's go ahead and do this one. Again, the key to finding the right area, well, one key to finding the right area is to find the left area. So even though it's asking the right area, I can use the chart to figure out these left areas. So let's find the left area for negative 1.38, shall we? All right, negative 1.38. We go to the front page. Still got some stray highlights around there. That's not what I meant to do. Hold on. All right, negative 1.38. Negative 1.3. And then the 8 column is here. Now, you may have noticed that the columns are shaded differently every other column. It's very subtle, but the even numbers kind of have a gray shading. The even z-scores on the top have a gray shading in their columns, and the odd ones are white in their backgrounds. All right, so negative 1.30, 1, 2, 3, 4, 5, 6, 7, 8. It looks like it's this. Except, I didn't mean to highlight that stray 3, except that is not the answer that we're looking for. Because what that represents is the answer to a different question. That represents the left area, 0.0838. So for those of you that were telling me, let's type this because my writing is getting kind of atrocious. There's no getting, it's always been that way. Left area was 0.0838. And several of you did tell me that that was your answer to the first question, which tells me that you were looking up the left area and not accommodating for the fact that it was asking for the right area. So just remember that the right area is 1 minus the left area, which is, in this case, 1 minus 0.0838. And the answer to that subtraction problem is 0.91762, which was the area that some of you had given me. So kudos if you got this for the right area on the first one. Before we go any further, does anybody have any questions about why the first one is 0.9162? And we can do the exact same thing on the second one. All we have to do is look up the left area for 3.10, and that's exactly what our chart tells us. Let's see, I just totally, sorry, my phone dinged and I totally lost the z-score I was looking up. 3.10, okay. 3.10, so we go to the very end of the chart almost. 3.1, and then the first column represents 0, so it's 0.9990 is the left area. So our left area is 0.9990, which means that our right area is 1 minus 0.9990, which is equal to 0.0010. So very, very small right area. And we got somebody in the chat. Just noticed you looked at the wrong number. Oh, it happens. There is a possibility of looking up something incorrectly in the table. Either when you go from the picture to the table, you get the digits mixed up, or when you go to the table, you accidentally look in the wrong row or the wrong column. All right, does anybody have any questions about these 2 right area questions so far? And the reason I said so far, that even though they're answered, I know this tells us left areas. However, it can also tell you right areas if you know how to look. So I have a challenge for those of you who have access to this right now, probably in the form of the PDF. Somewhere in the chart is this number. If I can get it to circle, is this number. So what I'd like for you to do right now is to reverse engineer the problem, meaning find this area somewhere in the middle and what z-score has that as its left area. I know it's a right area in this problem, but I could easily draw a picture where that would be its left area. And the question is, what would that z-score be? I'll pull up the chart here and we'll start browsing through it. And we're looking for 0.9162 in the middle. Well, it looks like it may be around here because these areas are all in the nines. 96, what was it? 9612, 96. I don't think it was 9612. What was it? Worst short-term memory in the world. 9162. See, I do it too. 9162. 9162, 9162, 9162. Found it. Did you find it? The answer to our question was in the Z chart, but it wasn't where we looked up. I'm sorry, my brain is all over the place now. I can't remember a single number. It wasn't when we looked up negative 1.38. So where was it? And I see the chats there. I'll get to them in a second. Well, the answer to our right area question was under 1.38. Huh. Interesting. Jordan, it would be 1.38. Lucas, same with you. And for some of you, this isn't a big surprise. But for some of you, you might have just had a little light bulb turn out where the area that we wanted from the right for negative 1.38 was the same as the area to the left of positive 1.38. So what's going on here? And let me do this on another slide because it's getting a little messy here, and we'll just draw a new set of bell curves. When we were looking for the area to the right of negative 1.38, we got our area was 0.9162. Right area equals 0.9162. But if you compare it to this picture, where we look at positive 1.38, but we look at the area to the left of it, then our left area here was also 0.9162. But it wasn't a coincidence. And the reason it wasn't a coincidence is because of the symmetry of the picture. In other words, and I can't really illustrate this well, but maybe I can draw a little goofy arrow. If we were to take the top picture and spin it around this line, then we would get the bottom picture because the negative 1.38 would wind up on positive 1.38, worst 8 in the history of 8s down there. And if we took the mirror image, then instead of being to the right, it would be to the left. And what it actually shows you is that there's another way to do a right area. Instead of looking up the left area and subtracting from 1, you can look up the right area of the opposite z. Now, the problem with having two techniques is that it's easy to get them mixed up. But I just wanted to point out that there is a way to get the right area directly out of the chart if you view the backwards picture and say, instead of finding the area to the right of a number, I'm finding the area to the left of its opposite. And I think my hands just went the opposite direction when I waved them on the screen. But you choose the way you want to do right area. For consistency, I will always use right area equals 1 minus left area, knowing full good and well that you can directly locate the right areas inside the chart by simply looking up the left area for the opposite z-score. I will always do right area equals 1 minus left area. All right, any questions on right areas on these two questions before we move forward? Okay, next skill I want you to be able to do is to find the area between two z-scores. All right. So area between two, finding the area between two z-scores. Finding the area between two z-scores. For example, and we'll just draw the picture directly. Let's say I give you this. You don't always have to put the 0 in the middle. I just do it for reference sometimes. Let's say I give you a z-score over here of 0.51. And over here, I give you a z-score of negative 1.07 and shade in the area in between. All right, now if you think you know how to find the area in between, I invite you to go ahead and do that. I'm going to go ahead and calculate it so I know what answer to expect. I know I haven't told you how to do it yet, but some of you are sharp enough that even if you've never seen a problem like this before, you'll be able to figure out exactly how to find that area between those two z-scores. Even though the z-chart only tells you the area to the left of a z-score. Make sure I get the right numbers. Okay, I've got what I think the answer is. So if you already think you know how to figure out the area between two z-scores, I invite you to go ahead and try that, and then I can compare my answer with yours. Now, there is a way to do this, and one of you direct chatted me and asked, don't you do this and that? And the answer is you're about to find out. The trick to adapting is to ask yourself, what does my chart tell me, but what do I want to answer? My chart only tells me the area to the left of something. So let's think about what would happen if we looked up each of these numbers in the z-chart. If we looked up negative 1.07 in the z-chart, it would tell me this piece right here. And if we looked up this number in the z-chart, it would tell me the area that I'm enclosing right now. It would tell me the area in that blue part that I just put a blue shape around. Like if somebody's not asking me what the answer is, they're telling me what the answer is. It's pretty bold of you, Lucas. Of course, you're correct on your answer. All right, so if you think about what happens if you look up both of these z-scores, and I don't know why I didn't put z equals in front of both of them. So we'll fix that real quick. And that 0 is kind of getting in the way in the middle, so toodaloo to you. All right. If you look up the negative 1.7 in the z-chart, it tells you the area shaded in green. And if you look up 0.51 in the z-chart, it tells you the area enclosed in blue. And if you notice, the green area plus the red area will give me the total circled by the blue. So if I want to figure out the red, I can just figure out the total area from blue and subtract the green area. In other words, all you have to do to find the area between is look up both z-scores areas and subtract the results. That's all. Let's see. I got something different, said Olive. All right, so let's go through the process real quick. Let's start with the larger z-scores area. Z equals 0.51. If you go to the z-chart and look up z equals 0.51, its area is right here, 0.6950. There we go, 0.6950. So the area to the left of z equals 0.51 is 0.6950. And we also know that the area to the left of z equals negative 1.07. Well, we just got to go look it up. Negative 1.07 is up here. Here's negative 1.0, and then we'll just count from left to right. 0, 1, 2, 3, 4, 5, 6, 7. So it's the last one that's highlighted, 0.1423. $0.1423. Oh, I didn't widen that text box enough. Give me 1 second here. There we go. So the area in between is the difference. So it would be 0.6950 minus 0.1423, which is equal to 0.5527. Or if you want to look at it as a percent, 55.27%. And that's how you find the area between two z-scores. You find the area between two z-scores by looking up both z-scores areas and subtracting the results. Does anybody have any questions about what I mean by looking up both z-scores area and subtracting the results? It's a really straightforward process. I'm just going to give you one to try. And so if you haven't tried it yet, I highly recommend trying it. And if you've tried it and haven't submitted answers either by text or by chat, then I highly recommend participating. All right, this one is for y'all. Let's see, I need to pick draw and put it in black. All right, so find the area. For the sake of convenience, I'll make both of these z-scores positive. We'll put one over here at 1.92, and we'll put the other one at 2.45. And by the way, every single problem that we're doing is a type of problem in your quiz. All right, the question is to find this area. I'll give you a second to draw the picture if you haven't drawn it yet, and then I will switch over so that the z-chart is on the screen. Okay, 1.92 and 2.45. Let me get rid of some of these highlights. Well, let's go to the correct part of the screen. Let's get rid of these highlights. Okay, I think everything you need is currently on the screen. I don't even remember what numbers I wrote down. They were 1.92 and 2.45. 1.92 and 2.45. The calculator turned off. 1.92. Oops. I wouldn't hit that decimal. Okay, I think I looked up the correct values. We'll see if anybody has the same answer. They're between this. Lucas, I appreciate how you changed your wording when you said the area may be. Okay. I'm getting something different than both Lucas and Lalith. That doesn't mean that you're wrong and I'm right. You can't both be right because you disagree. Only one of us could be right, and I am not sure who is. I'm not sure if it's me or the two answers I've seen so far. And it might be because I don't remember what the numbers were. So we'll take it one bit at a time. All right. So if we're going to find the area between, okay, Karina got an answer that agrees with me. So Karina, our answer is popular. So we'll say it's right, but that's not based on our opinion. So let's actually figure out what the correct answer is. All right, so if we're going to do this, the first thing we have to do is find the left areas of both of them. So we will start with the area to the left of 2.45. To the left of z equals 2.45 is, and that's just a matter of going to the chart and looking. Let's go ahead and set up all of these. Area to the left of z equals 1.92 is, so the area between is, we'll get a subtraction problem ready. All right, let's start with 2.45. All right, going to the Z chart. Okay, I'm getting more. Jordan got the same answer Karina and I got. All right, so going to the Z chart, looking at 2.45. 2.45 is right here. 2.4, and then counting across 0, 1, 2, 3, 4, 5. It's the 9299 number. So let's go write that in here. All right. 0.9299. And then for the area to the left of 1.92, going back to the Z chart, 1.92 is, let's change highlight colors. Let's use screen. 1.92, 1.9012, looks like it's 9726. 9726, 0.9726. And so the area should be the difference, 0. Something's not right. The area to the left of 1.92 can't be bigger than the area to the left of 2.45. So what did I do wrong? Had temporary dyslexia. I think some of you are pointing it out in the chat. Nope. But let me tell you, I don't care how good you think you are. I don't care how smart you think you are or how careful. Well, you should always be careful. That number that's currently highlighted is not the number that was in the chart. I typed 0.9299. In the chart, it was 0.9929. I have the two in the incorrect place. It should still be the highlighted in blue, 9929. Now, luckily, I was aware enough to realize that this number should have been bigger than that number. Since 2.45 is further to the right than 1.92, then the area to the left of 2.45 should have been bigger than the area to the left of 1.92. Now, I got lucky that I caught that, but I'm quote unquote the expert, whatever that means. So easy to make those mistakes. All right, so finishing it off, it's the larger area, 9929, minus the smaller area, 9726, which was 0.0203, or 2.03 if you want to write it as a percent. So for those of you who got 0.0203 or 2.03%, well done. Does anybody have any questions about why the answer is what it is? All right, we're just going to do that one area in between. We've got about 20 minutes left, and I've got a few more things that I would like to do. And it still just directly involves the Z chart. What we've done so far, just to review what we've done so far, is what I call forwards Z chart problems. In other words, I give you the Z and you tell me an area. Either you tell me a left area like we did here, 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 or here, or you tell me, or you determine a right area like we did here, here, and here. Comment about the symmetry of the thing, or give you two Z-scores and you find the area in between. But these are forward problems. In terms of the Z chart, a forward problem is when you start by looking on the edges and you find an answer in the middle. So for example, if I said find the area to the left of Z equals 0.97, then I would look on the edges for 0.97, and then my answer would be on the inside. So I go from the outside in. So it's a backwards problem. Well, in terms of the chart, it's inside out. But in terms of the picture, it's where you start with the area and then you find the Z-score. And yes, we have scenarios where we have to do the process backwards. It's not any more difficult than you might think. You just have to stay cognizant of what you're told versus what you want to find. So for this next skill, it's finding, I can spell the Z when an area is given. And there's three variations of this. You'd probably figure out what two of them are really easily, especially since this first example is going to tell you exactly what type of problem it is. Now I'm going to reverse the process. I'm not going to tell you a Z, but I'll tell you the area to the left of it. And so here's the question. The question is, find the Z-score whose left area is 0.9082. And again, the trick to using the Z chart is to constantly remind yourself, what are you telling me and what do you want from me? In this case, I'm being told an area, and what I want is the Z. It's supposed to be drawn. 1 second. What I want is the Z. Now it's kind of evident from the picture, but I already know the Z I'm looking for is bigger than 0. In other words, it's positive. Because if it were in the middle, the left area would be 50%, but it's bigger than that. So the Z has to be further to the right than 0 is. All right, so if you haven't done so already, I invite you to dig out the Z chart and see if you can find the area in the middle of 0.9082. And the question is, what is that Z score? And I don't remember because I just grabbed the number in the middle, but Miss Olvera, it looks like it's the correct Z score. And we got another answer from Lucas and from Dylan. And all 3 people have submitted solutions so far, all 4 people. Thank you, Ms. Bartholomew. All 5 people who have submitted answer all had the same score. And it would be a shame if they were all wrong, but they are all correct. The Z score is 1.33. It's a little trickier doing the process backwards because you have to scour through all these 4-digit decimals and look for the particular value that you're being asked to find, which was 0.9082. Now, the good news is these Z scores, for the most part, are increasing as you go from top to bottom. So if you were to look, and we're just going to do a lot of highlighting here, if you were to go across the top, now across the top, they're pretty constant, but as you move down, you notice they start increasing. The Z scores are increasing, and they increase as you move from left to right. I stand corrected. On this side, they decrease as you move from left to right. But it's almost like you're reading a, I forget what language is right from right to left, but if you're going top to bottom, right to left, these are increasing. However, knowing that the area I'm looking for is more than a half, I should immediately go to the back side of the page. 9082 is what I'm looking for. So let's go to the back side of the page. And you can almost treat this like, let me just look in the first column until I find something in the right neighborhood. I'm looking for 9082. When I get down here, that's too far, so let me back up. Probably going to be in one of these 2 rows, so I'll just start looking across, and I found it. It's right there. I'll highlight it in another color in addition to green. Ooh, that's ugly. Makes it hard to see. It's right there, 9082, right there. And the Z score associated with it is 1.33. And that was the answer that everyone had given me. So well done if you found the correct Z score of 1.33. Answer Z equals 1.33. So looking at the left area is really just a matter of digging for it. It's buried in there and you have to find it. Be patient. The numbers are in some sort of order, so you should be able to find it. Let me throw one more out there since now I've kind of let the cat out of the bag. And kudos, well, I take that back. There was nothing to figure out here. It was just literally doing the problem backwards. All right, well, let's just throw one more just for good measure. I'm not even going to draw the picture this time. Just gave you the left area. Left area equals 0.1922. The question is, what is the Z equals? Now, you can probably figure out right away whether the Z should be positive or negative based on how large or small the area is. And that was supposed to be a question mark there. On a test, I will ask you to draw a bell curve every time you do a Z problem. Not just look up the answer, but draw the picture that goes with it. Because the picture can really help you focus to help you stay focused on the task at hand. If you find the Z, drop it in the chat. And if you need the Z chart, I'll bring it up, but I hope you have the area written down. 1922. Where you need to look is not in that green area, but it's below that green area. 1922 is what you're looking for. It's not even on the screen. Now it's on the screen. And let's see what we got in the chat. Yes, yes, and yes to Lucas, at Lalith, and Dylan. And I appreciate those of you who are participating in the chat. We have 30 people on the chat last time I checked. Well, 29 plus me. So we're having about a 16% participation rate. Be nice if it were more. but and Miss Bartholomew got it also. All right, so the good news is some of you are killing this. I hope the rest of you are killing it, because I want to remind everybody. And very good, Ms. Eklund, you got it also. And Karina, all right, so the answers are flowing in. I stand corrected. One of you has an incorrect answer. I will tell you that the answer should be negative. So for the person who had the positive answer, numerically it was correct, but it should have been negative. And I want to remind everybody before we answer this one that your quiz is over the skills that we're doing right now and is due before class time on Wednesday. It is set to be due at 4:05 p.m. on Wednesday. So hopefully everybody can knock it out. If I were you, I'd knock it out as soon as we're done. Just get it over with. All right. So the number we were looking for was 1922, which is right here. And the z-score associated with it, if you look to the left, it's negative 0.8. And this is under the 7 column. You can count it from left to right, or you can scroll up and see that it is the 7 column. So negative 0.87. All right. Excuse me. So very good, everybody. And by the way, I knew the answer had to be negative. Somebody gave me a positive answer, but here's the reason why it couldn't be positive. 0 cuts it in half, and that's not the perfect bell curve, but mine never are perfect. I want a left area that's less than a half, so it has to be over here somewhere. And being to the left of 0, I know it has to be negative, but it was negative 0.87. All right, so looking up a z when you know the left area is pretty straightforward. There is the situation where the area you're looking for is not exactly in the chart. We'll talk about this more later, but in general, if the area you're looking for is not exactly in the chart, you choose the area that's closest to it. All right, we got a couple of more fish to fry, and then we'll be done. Let's see. If I give you the left area, find the z. Oh, if I give you the right area, find the z. Find the z that cuts off a right area of, let's say, 0.0344. Now I'm going to sketch this picture, and it's always a good idea to sketch a bell curve anytime there's a bell curve to be sketched. 0.0344, making sure that was in the chart. All right, so before I do anything, will this z be positive or negative if the area to the right is about 3%? Will the z be positive or negative? And it's important to think about these things before you go jumping in the chart. What do you think? Positive or negative? Will the z be positive or negative? Got positive from Karina. See if anybody else has an opinion. And again, if the z cuts off a right area of 0.0344, it'll be positive or negative. Let's see, get another positive from Ms. Bartholomew. Question from Ms. Olvera. All right, now some of you have already realized that because this is a right area, there's going to be some issue. And so we got to resolve that issue. It has to be to the right. Because if we cut off in the middle, the right area is 50%, but we need a smaller right area. So our z has to be further to the right than 0, and that's going to make it positive. Now, if you did not pay attention to where it said right area and just directly looked up 0.0344, it would be right here. But that z-score is negative 1.82. And if you had already decided that the z had to be positive to cut off a small right area, there's no way negative 1.82 could be the answer because it's supposed to be positive. So how do we do this? Well, there's a couple of ways to do it, but I want to always focus on what our chart tells us, which is left areas. So the way that I'm going to recommend doing this, and some of you are going to immediately see another way to do it, but the way I'm going to recommend doing this is to look up the left area. So first, we're going to find the left area, which is 1 minus 0.0344, and that's equal to 0.9656, I believe. 96, yes. Then look up that left area. And if we look up that left area, you should get z equals 1.82. I'll verify that here in just a second. We're looking for a left area of, what was it we were looking for? 0.9656. Left area of 0.9656 is right here. And that is with z equals 1.8, and it is in the 2 column. It's the 3rd column, but remember the first column represents 0, 0, 1, 2. All right, so that's one way to find the z-score when you're told the right area. Now, as some of you are already going to say, well, I looked up the area and it was negative 1.82, but I know by symmetry, I needed the positive version, so it's 1.82. And that's actually a faster way of finding a z when you're told the right area. Look up the right area, but keep in mind that your sign is going to be incorrect. You pick the method you want to do for right area. Either subtract from 1 to get the left area and look that up, or just look up the right area and remember that the z you look up has the incorrect sign, and it is 1.82. All right, does anybody have any questions about the right area problems? We're only going to do one more type of problem, which is good because we only have 6 minutes. The last type of problem, well, if you're good at pattern recognition and see what we've done so far. We started out by finding areas to the left of z's, then to the right of z's, then between 2 z's. And now we're doing it backwards where we're told a left area, and now we're told a right area. And so now you might be thinking we're told a between area. And you're kind of correct, but reverse engineering a between area problem is almost impossible, because think about what you would have to do. If I gave you the answer to this and asked you what the 2 z-scores were, to go backwards, you would have to first create a subtraction problem with the correct answer and hope the 2 halves of the subtraction problem were inside the z-chart. That's a little bit too much to ask, because reversing a subtraction problem without any hints as to what that subtraction problem was is like looking for a needle in a haystack. So we won't necessarily be doing the reverse version of between unless the area we're given is exactly in the middle. So the last type of problem is finding the z-scores, plural, that cut off a middle area. Not just between 2, but actually dead center. For example, let's say I gave you this picture. I'm going to put it in black, but we'll leave it in red. And I tell you that I want to cut off. Folks, I'm sorry, I have to go outside real quick. My dog is yelling. I'll be right back. I'm sorry, folks. The question is 95% in the middle. Find the z's and cut it off. I'm sorry. Hold on. Ollie, come here. Come on. Oliver. Ollie, come on. Sorry. Oliver, come on. Ollie, come on. I'm so sorry. I really thought he was caught in something. He's a little bitty Chihuahua, and we've got lots of vines that grow, but he was just yelling at the dog next door, because the dog next door is big and scary, and little Chihuahuas are just always brave. All right. Sorry about that. I really thought it was caught in something the way it was yelping. Okay. So now for the last task, the last skill, we're going to find the z-score that cuts off a middle area. And the reason we're doing this is because of building confidence intervals. You may remember that when we had a confidence level that represented the middle area, and we had to find the values that cut off that middle area. When we get to our formulas for confidence intervals, those formulas will require knowing these z-scores. So let's think about how to reverse engineer this based on what our z-chart tells us. Our z-chart tells us left areas. And if we're doing a backwards problem, we need to know a left area. So my question to anybody who wants to chime in, is this still recording? Yes. My question for anybody who wants to chime in is, if the middle area is 95%, can anybody tell me just this left area? either as a percent or as a decimal. And I'll give you a hint. It would be the same answer as the right area because of the symmetry of the picture. So what would that area be? We've got the same answer for everyone so far. We got 1, 2, 3. Did you really say 5 halves? Interesting. I would have said 2.5%. Now I want to warn some of you because some of you are saying 2.5 and some of you are saying 2.5%. And it's important to understand the difference between those two. If we're measuring the area in percent, then this area has to be 2.5%, not 2.5, because altogether, all the percents have to add up to 100%. And if you're wondering where the 2.5% came from, it's simply half of 100% minus 95%. In other words, if we did 100% minus 95% and divide that by 2, we would get the 2.5%. But the reason it's important to know that it's 2.5% and not 2.5 is that we're going to look up this left area, and in the Z chart, they are decimals. So I have to start with the percent, turn it to a decimal by saying 0.025. And knowing that I'm looking up this area in the middle of the Z chart that has 4 digits, I need to throw another 0 in there and look up the Z that has a left area of 0.0250. And I know exactly what it is. I get the feeling some of you do, because you've told me, okay, well, you all told me the percent. And I'm sorry, I didn't give you the opportunity to look up the Z-score, but we're short on time. So I'll tell you right now that it would be Z equals negative 1.96. And by symmetry, this one would be positive 1.96. All right, we've hit 5:30. So here's what I would like for you to do. I know we only did one example of finding the Z's that cut off the middle area, but it's a story we've heard before when we talked about confidence intervals. I need you to go into Canvas, take your quiz. You get 2 shots at it. So, try it once when you want, but the questions are just like the ones that you've seen today. Finding Z's, finding the area to the left, right, and middle of 2 Z's, and then given a left area, right area, or center area, find the Z-scores that cut that off. I expect you to contact me if you have any questions, but at this point, you can consider class done. You're welcome to go. If you have any questions, you can drop them in the chat. I will be ending the Zoom session in about 5 minutes so that I can get ready for my next class. And I appreciate you joining me today. You are welcome, Ms. Olvera. You are welcome, Mr. Martinez.
Professor.
Oh man, people disappeared fast. 4, 3, 2, 1.
It's just
Looks like
me
Aaliyah and
other
Gabe are the
person,
only
yeah.
ones left. All right, well, I'm going to go ahead and end the Zoom session, Gabe, Aaliyah, so that I can get ready for my next one. I will post this recording on Canvas.
Wait. Oh,